Dear friends, we start with second lecture of Mat 304. So initially, I start with one more sum of simplex method. Maximum z is 3x1, 2x2 plus 5x3 subject to 2x1, 3x2 less than or equal to 8, 2x1, 5x2 less than or equal to 10, 3x1, 2x2, 4x3 less than or equal to 50. So here you know that we introduce slack variable z plus s1. This is slack variable. Here we add one more slack variable plus s2, and here we add third slack variable plus s3 equal to 15. So s1, s2, s3, they are not in the objective function z. So if they are there, means there will be 0 s1, 0 s2, 0 s3. Means they are there with zero cost coefficients. They are there with zero cost coefficients. And s1, s2, s3 are slack variables. You can see on the board by zooming your mobile phone or the instrument, maybe whatever you are seeing, you may zoom it and see it. If you have some problem to see on the board. Now I want to feed up all this information in this one. So S1, S2, S3, they are basic variables. The cost coefficient are 0, 8, 10, 15, 2, 2, 3, 3, 5, 2, 0, 0, 4, 1, 0, 0, 0, 1, 0 and 0, 0, 1. As I used to say you in each lecture, use your pen and pencil, pen or pen and paper to write the information or to write the sum, solution of the sum. Whenever I am writing on the board, we should keep it on and on. So delta j of basic variables are 0. You can see here 0 into 1, 0, 0, 0, 0, minus 0 for S1, S2, S3. Now here it is minus 3, minus 2, minus 5. So this is the most negative. So 8 upon 0, 10 upon 0, 15 upon 4. So only one minimum positive ratio, and that is this one. Please see on the board very carefully. Actually it is infinity. So this is our key element. Now we divide this row by 4. So it is 15 by 4, 3 by 4, 1 by 2, 1, 0, 0, 1. And we wanted 0, 0 here. But this is a first sum in which it is already 0. So we have to do nothing. Just copy it as it is. Value of z is 0, 0 into 8, 0 into 10, 0 into 15, 0. 2, 2, 3, 5, 1, 0, 0, 1, 0, 0. Here it is S1, S2, S3 is now X3, and therefore it is 5, 0 0. So value of z 75 by 4. 0 0 15 by 4 minus means it is 3 by 4. 0 0 5 by 2 minus 2 means it is 1 by 2. 0 0 0 divide this by 4, so it is 1 by 4 there, and therefore it is 5 by 4. Therefore, fortunately this is a solution. And what is solution? Maximum z is 75 by 4. X3 is 15 by 4. X1 is not in the base, X2 is not in the base, means they are with value 0. You have to do nothing. Clear? This is solution. Here we proceed for one more sum. Example 4. Maximum z equal to 3x1 plus x2 plus 5x3, subject to this condition. As all of they are in the less than or equal to form, we have to add 3 slack variables, and I put space for slack variables there. So plus s1 plus s2 and plus s3. Therefore, are slack variables. Now we put all these values here. For S1, S2, S3 it is 1, 0, 0, 0, 1, 0 and 0, 0, 1. So now we proceed for X1, X2, X3 and it is 1, 3, 1, 2, 0, 4, 1, 2, 0, 4, 3, 0, 4, 6, 0, 4, 2, 0. Check it once more. Check it all these things once more, how I put these values here in the table. Next we calculate delta J. For basic variables it is 0, minus 3, minus 1, minus 5. So obviously minus 5 is most negative. So it is xb upon xa means 430. And this is infinity. So it is not in calculation, or you may write it infinity. Okay. So if you write infinity, it is not necessary to write plus there, it is infinity. Now among these 230 is minimum 1. So this is key element. Now what we are going to do? We have to divide this equation by 2, and therefore it is 230 divide this equation by 2. 3 by 2, 0, 1, 0, 1 by 2, 0. Then I want 0 at both these places. But fortunately there is 0. So we have to do nothing there. Means it is 4 to 0, 1, 4, 0, 0, 0, 1. Then I want 0 here. For that we have to subtract these two equations. So it is 200 minus 1 by 2, 2, 0, 1, minus 1 by 2 and 0. So this table is over. So x2 is out of basis and therefore it is s1. x3 is inside basis s3. This is 5, these are 0. So value of z is 1150. 15 by 2 minus 3. So it is 9 by 2. 0, 0, 0, minus 1, 0, 5, 0, minus 5 is 0, 0, 0, 0. It is 5 by 2 and it is 0. So only one negative there. Check this table once more. (200 minus 1 by 2, 2, 0, 1 minus 1 by 2, 0, 230, 3 by 2, 0, 1, 0, 1 by 2, 0, 40, 0, 1, 4, 0, 0, 0, 1, 9 by 2, minus 1, 0, 0, so only one negative there. So now again we apply to find the ratios xp upon xj. 100 105 and therefore 100 is minimum one and therefore this is key element. Therefore we divide this equation by 2. So it is 100 minus 1 by 4, 1, 0, 1 by 2, minus 1 by 4, 0. Then I wanted 0 at both these places. Fortunately there is 0. Therefore we have to do nothing for this row. So it is 230, 3 by 2, 0, 1, 0, 1 by 2, 0. Then I want 0 here. For that I have to multiply this equation by 4 and subtract from this, or multiply this equation by 2 and subtract from this. So it is 20, 2, 0, 0, minus 2, 1, 1. And therefore x2, s2, x3 and s3 0, 5, 1. (15 by 2). What is this calculation? 15 by 2 minus 1 by 4 minus 3. So it is 30 by 4 minus 12 by 4. Means this is equal to 29 minus 12. So it is 17 by 4. It is 0. It is 0. 1 by 2 minus 1 by 4 plus 10 by 4, 9 by 4, 0, 0, 0. So all delta j greater than or equal to 0. And therefore maximum z is 1250. So this is solution. Therefore solution is maximum z equal to 1250, x1 is 100, x2 is not there, therefore it is 0, and x3 equal to 230. This will be the solution. Dear friends, please see this sum at least twice, because it is different as we solve the previous sum and this sum, and therefore there is something new. About two things are there which are new, and therefore you have to understand that what is difference in the previous fourth sum, and as this is the fifth sum, this is different sum. Check this. Okay. Now what is difference? Solve by big M method. This is something different for you. What is big M? Big M is a special type of simplex method, and which is also known as a penalty method. Here the difference is that which we have not seen in the previous sums is equal that. Here it is equal to 3. This is greater than or equal to. We are used to for less than or equal to form, and therefore here we can use slack variable. But what about these two? This is new concept for you. This is new inequalities for you. Here it is equality, here it is greater than or equal to. For that we wanted what we wanted? Basic variables. Basic variables means they are in the form of 1, 0, 0, 0, 1, 0 and 0, 0, 1. But there is no sum like this one. For that we introduce, see here, whenever there is equality, for that we have to introduce new type of variables. They are known as artificial variable. Here I am going to introduce one more variable, and that is A1. Artificial variable. Here it is greater than or equal to, I introduce minus S1. This S1 is surplus variable, and for here now minus S1 is there, but now this satisfies for us. 1, 0, 0 is there, but there is no 0, 1, 0, and for that I introduce one more variable, and that is artificial variable. I introduce A2, and in the third one I introduce S2, and this S2 is surplus variable. Therefore A1, A2 are artificial variables, where S1 is surplus variable. And S2 is again slack variable. So here I again repeat, a1 and a2 are artificial variable, s1 is surplus variable because we subtract it, and s2 is again slack variable. Here we have to introduce all these things in the objective function, and for objective function it is minus ma1 minus ma2. We should keep value of capital M equal to 100 in our mind. We should keep value of capital M is 100 in our mind, but we are not writing anywhere. Just for simplification I am giving this hint to you. Again, this is a new sum. Here it is equality. Just add artificial variable. Here it is greater than or equal to, subtract surplus variable and add artificial variable. This is less than or equal to. To make it equal, we add only slack variable. Okay, there is nothing more. If equality, direct artificial. If it is greater than or equal to, subtract surplus, add artificial. And if it is less than or equal to, direct slack variable. Very clear, very straightforward. And there is one special thing, is in the form of objective function, the difference is minus ma1 minus ma2, means how much artificial variables are there, we subtract by negative values, and therefore we call this as a penalty method. Dear friends, I stop here with this note, and I will solve this sum in the next lecture. Thank you very much.